Washington, a report on the case of the trailing vortex. Studies of unique air turbulence created in the wake of large air transports. That's the story. Willard Scott reporting. Details coming up. This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. A vortex, plural vortices, is roughly defined as a whirling, swirling, spiraling mass of air or fluid. The motion of a whirlpool is a vortex, as is a tornado, a waterspout, or some other type of major storm system. Vortex is also associated with the field of aeronautics as an event which trails behind large air transports in flight and which poses a significant threat to small planes flying nearby.
Well, trailing vortices are a product of the lift generated by the airplane. We can visualize these vortices as being cylindrical masses of air trailing rearward from the wingtips.
That's William A. McGowan, NASA aeronautical engineer, involved in the current nationwide effort to pin down the whats and whys of trailing aircraft vortices. Have you ever been driving your car and been passed by a large truck traveling at high speed? Well, if so, you've probably felt the impact of the trailing wake of air as it went by. Bill McGowan explained that in some respects, this is similar to the vortex problem being studied by aeronautical engineers.
Well, they certainly disturb the air, and you can feel the results of this disturbance. The vortex is more defined, I think you would say, than the turbulence created by the truck. It's really a whirling mass of air that does resemble a tornado. Oftentimes it isn't of near that much concern to us as a tornado would be, but it can be of velocities that would be of concern to a light plane pilot, say, if he encountered these near enough to the airplane that was generating the vortices. Now, the problem with the wake in the airplane is that you can't see it. And this is why it would be very beneficial to determine the movement of the vortices once they're generated and how long they persist, so pilots can be informed of this and stay out of this region.
Mr. McGowan continued that engineers and pilots have known about the vortex problem for many years now. But until the appearance of large transports on the order of 100,000 pounds and up, no particular threat was posed to smaller planes. Well, now, with aircraft approaching the 1 million pound size, work on identifying and understanding the sizes, velocities, locations, and persistence of vortices is intensifying. The FAA has established rules and safety guidelines for pilots of small aircraft as to how to avoid areas where vortices may present a problem. At the same time, several NASA research centers are studying vortices from a number of perspectives, including wind tunnel research and actual in-flight investigations, all in an effort to better understand the trailing vortex and, in turn, better inform pilots as to how to cope with them. Again, aeronautical engineer William McGowan.
With the current program underway, we will know a lot more about them than we have in the past, and I think this information will be used quite handily in predicting what new airplanes will generate. But too, I think we sort of say this with a little bit of caution, that we've been working on lift and drag since the start of flight. The problems never really go away. We just keep refining them, learning more about it, and thereby building more efficient airplanes, more economical airplanes. And I think that as the airports handle more traffic, that we're going to have to refine our knowledge on the trailing vortex problem just to cope with increased traffic at airfields.
This has been the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott speaking. San Francisco, California. Preliminary plans for investigating the outermost planets of the solar system via automated spacecraft. That's the story. Willard Scott reporting. Details coming up. This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. The mission is generally known as the Grand Tour and involves a visit by unmanned spacecraft during the last half of this decade to the outermost planets in the solar system: Jupiter, Saturn, Neptune, Uranus, and Pluto.
Starting in about 1976 or 1977, the planets are aligned in such a way that by first sending a spacecraft to Jupiter, we can use Jupiter's gravitational field to divert its course and to send it on a subsequent leg of the trajectory towards Saturn or towards Uranus. And similarly, at Saturn or at Uranus, we can divert it again using that planet's gravitational field to send it on to a further target. And the advantage here is that by using that gravitational field to change your trajectory, you avoid having to do it with propulsion systems. And this results in us having available to us a very much low energy mission than we could fly if we went directly to one of the outer planets.
That's Dr. Paul Swan of the Mission Analysis Division at NASA's Ames Research Center near San Francisco, California. Dr. Swan and his group are in the business of planning possible space missions of the future and determining well in advance the technological requirements of such missions. The so-called Grand Tour of the Outer Planets has been on the planning boards for some time now. The missions themselves are still tentative. The peculiar alignment of the outer planets occurs about once every 200 years. The 1976 to 1979 opportunity would allow one or more automated spacecraft to swing by these planets and scientifically investigate them, using the gravity field of each to, in effect, whip the spacecraft onto the next planet. To take advantage of the unique alignment of Jupiter, Saturn, Uranus, Neptune, and Pluto, Dr. Paul Swan explained that spacecraft would have to be launched between 1977 and 1979.
NASA's present plans, and these are not approved, but are tentative plans, are to send one or more spacecraft in the 1977 launch opportunity to Jupiter, Saturn, and Pluto, and then to send one or more spacecraft in a 1979 launch opportunity to Jupiter, Uranus, and Neptune. Whether or not you send more than one spacecraft at a given opportunity depends on how you want to tackle the problem of reliability and how you want to tackle the problem of coverage of the planets when you encounter them. You'll recall on the Mariner 6 and 7 missions that we sent to Mars just recently, one of the spacecraft went around the equator, so to speak, and one went down under the South Pole. And so you can use two spacecraft to very great advantage to look at different parts of the target planet that you're looking at.
Dr. Swan continued that spacecraft taking the Grand Tour would likely carry television cameras on board, together with other sophisticated instruments, to examine the makeup and composition of each planet in detail as the vehicles fly by.
In addition to these flyby spacecraft, the possibility is beginning to appear that we will carry along probes that we can detach from the spacecraft and send into the planetary atmosphere. This is technologically very difficult, but the people here at Ames are studying the problem of thermal protection for such an entry probe. So although there is nothing in our detailed planning yet, we're investigating the possibility of trying to add such probes to the flyby spacecraft.
Dr. Paul Swan, and comments on preliminary planning for a grand tour of the outer 5 planets in the solar system. The story from NASA's Ames Research Center, San Francisco, California. This has been the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott reporting.